I was here a couple of weeks ago, Pascal, looking at the Fanuc D21 Robodrill. We've come back today and we've come to look at the high power version. Can you tell us some of the differences and why the high power version has been introduced?
The high power version has been introduced, Paul, to compete with the BT40 market. It increases our capacity for drilling and our capacity for milling.
And is there any examples of that? I mean, how much power has the spindle got and what are the...
Well, the spindle powers over the recent years have increased from 5.5 kilowatt, then the next version went up to 11 kilowatt, and now we're up to 14.2 kilowatt on power.
So that's a big leap.
It's a lot big leap.
How has that come about and what's the technology
Fanuc
involved?
have done a lot of research and development over the years on the construction of the spindle with the stainless steel ball bearings and high precision ball bearings that they have in there, and made it a lot more rigid. So it's the rigidity of the spindle design that has been able to give it that type of capability.
So has this opened up new markets for you?
It certainly has opened up new markets with respect to cutting steels and exotic materials, and also they've implemented the Big Plus spindle with it as well to make it even more rigid.
Okay, so what does the Big Plus involve?
The Big Plus spindle involves face and taper contact on the back hold of the tool.
And that gives what, more rigidity?
More rigidity. It stops that bell type ringing in the spindle that you get with a normal taper.
And with the torque that we're talking about, does that mean, what is the spindle speed? Are we compromised there? Is it slightly slower?
No, the spindle speed, we've got the high torque, high power machine, which is the 10,000 RPM machine. It's got no compromise on speed whatsoever. Okay. The torque probably kicks in around about 1,000 RPM.
So when we're looking at speed and high speed machining, how quickly can this machine go from 0 to the top speed and the torque change time?
The previous versions, it was 2.9 seconds, and now we're down to 1.3 seconds, a reduction of 52%.
What chip to chip?
10,000 RPM, tool change back up to 10,000 RPM.
2.9 seconds down to 1.3.
52%.
And how have they achieved that?
Good question. Well, I think if they know that, all our competition would know.
So what sort of company would actually go for a machine like this?
Probably a customer who does a lot of contract work, where he doesn't know what type of work is coming around the corner. So he won't necessarily invest in a high-speed machine, high-speed 24,000 RPM, because he may be cutting steel one day, aluminium the other day. So it gives them a good general broad sort of like base of what type of materials he can cut.
So it would be fair to say that if a machinist was looking at a BT40 machine, depending on the application, the Robodrill, even with the BT30 with the Big Plus, could actually be a consideration.
Could be a consideration. Where we would probably fall back on the BT40 would we wouldn't be using things like 150mm face mills. Right. But when it comes to face mills under 80mm diameter, then the machine will be able to run at the same cutting data that BT40s can.
And so for the benefit of our viewers then, is there anything that we can quantify, any drill diameters, any depths, any face mill diameters and depths of cut?
Yeah, for example, in the EN8 we can drill using a 40mm U-drill that can go through. I can't confirm the actual speeds and feeds we use at the moment, but
a 40mm U-drill?
A 40mm U-drill will cut at the cutting speeds recommended by the cutting people.
And what about face milling? Is there any sort of...
Face milling, again, it's because of the face and taper, we can go 5mm depth of cut in steel on a 40mm face mill, no problem.
And how would that then compare to the BT30? Is it twice as...
No, I think what it's doing, it's reaching towards the BT40. In other words, it's not a complete match, but it's getting much more near competition than what it ever did before.
So prior to this conversation, one of the comments from your colleagues is about the reliability of the Fanuc machines. A big plus, a big point for you guys?
Oh, without a doubt, without a doubt. I went to see a customer last week, got 20 machines in there, ranging over 20 years, from the 120 years and to the latest ones as well. All the machines were running at that customer's.
So it gives your service department either an easy life or a problem.
Well, yeah, I mean, we don't make too much on spare parts because we don't sell a lot of spare parts, to be honest with you.
That's good news. And in terms of the high power version, so there are options with the machine. You can go for the 10K with a high power, but you can't go for a higher speed spindle than that, or can you?
You can go 24,000 RPM, high speed spindle.
But is there any compromise in the power?
The compromise on the power is you haven't got the torque that the 10,000 RPM machine has, but you have obviously with the small cutters doing small type detailed work on aluminium type work, it's ideal. Cutting electrodes and that type of 3D type work.
And in terms of applications, I note from a previous video, you can have a 4th and 5th axis on this machine,
correct, yeah.
Fully integrated into the Fanuc control. Is there any new features with the Fanuc control that give it advantages over other controls?
The Fanuc 31IB control, it's a 31IB5 control with an R5 axis, and we have the capabilities using all the 5-axis functions that most customers need to do their 5-axis machining, whether it's impeller machining or 3+2.
But that would be programmed offline?
That would be programmed definitely offline, yeah.
Okay, great insight into it. Pascal, thank you very much for your time. Okay.